Hi, these are the frequently asked questions for our section 6.2 practice worksheet from 6.2 day 3. And I'm going to start with number 18. And yes, I know that you didn't do number 18 because we were doing odds, but I think it's a tougher problem than you see in number 17. So since you're doing 17, I'll show you 18 and then you could go back and do 17. So with number 18, they're both cubed roots and we're supposed to multiply them. So that's exactly what we would do. We would figure out what 50 times 15 is, whether or not you're using a calculator or not. So 750. And then we'd have x squared, y cubed, and z to the 6th. Because reminder, when we have similar bases, we add the exponents. Now we're going to separate this because remember, numbers behave differently than variables do. So I have the cubed root of 750 and the cubed root of x squared, y to the 3rd, z to the 6th. Now with the cubed root of 750, what I want to do is use those numbers in my power chart to see if I can divide any of those evenly into 750. And since it's 750, the first number that came to mind was 125. And that goes into it 6 times. So we'll be able to simplify that 750 because it's the cubed root of 125 times the cubed root of 6. And now we'll need the cubed root of x squared, which of course that's not enough to make a full x value out of. We need the index to match or our power to be higher than what we have with the index. But cubed root of y to the 3rd, that will work out nice. And then cubed root of z to the 3rd and cubed root of z to the 3rd together will give us cubed root of z to the 6th. Now the reason we wanted the cubed root of 125 is because that's a 5. Cubed root of 6 is not something nice. Cubed root of x squared is not something nice. But the cubed root of y to the 3rd is nice. It's a y. And the cubed root of z to the 3rd is nice. It's a z. So the pretty stuff is 5y z squared. And the ugly stuff is the cubed root of 6x squared. And that should be done. And again, in alphabetical order is usually the way that we write it, so the y's before the z's. That's number 18. The next one that I wanted to go over with you, as you can see in the red up here, is number 23. And number 23 was one that when I was wandering around today, several people had asked about this one. So we've got the cubed root of negative 9x squared y to the 4th times the cubed root of 12xy. So what we would need to do is multiply negative 9 by 12 and see what we get. And that gives us negative 108. And then again, with similar bases, we add the exponents. So we have a 2 and a 1 for our x's for a grand total of 3, and a 4 and a 1 for a grand total of 5 for our y's. And now we're going to separate the number from the variables. And we want to figure out, well, is there something nice in our cube roots that will divide nicely into 108? So we give it a try, and we say, how about negative 108 divided by 64? That does not come out nice. Negative 108 divided by 27. Yes, that comes out nice. So we want to take the cubed root of 27 out of the cubed root of negative 108. And we also want to take the negative whenever we can. So we're going to take the cubed root of negative 27 and the cubed root of 4. And then we'll have the cubed root of x to the 3rd, the cubed root of y to the 3rd, but there's still 2 more y's that we need to deal with. The pretty stuff, cubed root of negative 27 is negative 3. Cubed root of 4, that's not nice. Cubed root of x to the 3rd is x, cubed root of y to the 3rd is y, and cubed root of y squared, not pretty. So in the front we have a 3, an x, and a y, and then in the back we have the ugly cubed root of 4 and y squared. So that was number 23, and that one is finished. Next up, I have number 27. Now, number 27, we can see 54 is divisible by 2, so the first thing we would do is make this one big fraction and simplify as much as we possibly can. So it's the square root of 54 divided by 2 is 27. X to the 5th divided by x squared. When we divide similar bases, we subtract exponents. So that's x to the 3rd. And same thing with the y's, but we have a 3 minus 1 this time, which will be y squared. And now, just as we were doing before, we want to separate the numerical part, the number, from the variables. And the square root of 27 does have a perfect square that will go into it, and that's going to be 9. And then we can have the square root of x squared, the square root of x to the 1st, and the square root of y squared, because together I need x to the 3rd y squared. Square root of 9 is nice, it's 3. Square root of 3 is something we're just going to hang on to for a little bit. Square root of x squared is x. Square root of x, we're going to leave that. And then square root of y squared is y. And let's put all the pretty stuff in front. 3xy, square roots of 3x. So that was number 27. The next one that I have up here that I wanted to go through with you is 29. 29 is another one where when you first look at it, you realize, hey, if I made this one big fraction, I can go ahead and do some reducing because x goes into both the numerator and the denominator. So that'll give me the cubed root of 4x. And that's done. We don't have any perfect cubes that will go into the 4, and nothing we can do with cubed root is going to help that little x that's sitting there. So that problem is finished. Next up is 33. Oh, you know what? I'm going to add 31 while I'm here, because I know that people had asked me about 31 while I was wandering around today. And most people probably overheard me talking to other groups about 31, because in number 31, we have to follow the order of operations. It doesn't matter if we're working with radicals or what we're working with. We follow the order of operations. So what we have to do first is 2x times 2x, and in the denominator, 5y times 5y times 5y times 5y. So in the numerator, we'll have the square root of 4x squared, and in the denominator, we'll have the square root of 625y to the 4th. Well, we can separate this for the numerator, and that's going to work out perfect. That's 2x. So that gets you thinking, what about the square root of 625? I mean, that's a much larger number than we actually went up to. We went to 15 squared, but maybe the square root of 625 is something nice. And we punch it in the calculator, and we see that's actually 25. So that's a nice perfect square. And then for our y to the 4th, we'd have the square root of y squared and the square root of y squared, which of course is y and y, and together they make y squared. So that one wasn't so bad once you get past that first step of remembering, hey, I have to do parentheses first. 33, square root of 162a over 6a cubed. We have some pretty obvious canceling we're going to be able to do with a, but let's check out 162 divided by 6 and make sure that's something that we can work with. So that goes in 27 times. So we'll have the square root of 27, and this is all taken care of here. And then what we have to do is say, here's 1a, and that'll cancel out, so I'll have an a squared on the bottom. So I have the square root of 27 over the square root of a squared, and the square root of a squared is just a. The square root of 27, 9 goes into that, and that's one of our perfect squares. So this will be 3 square roots of 3 all over a for number 33. Then the last two are 38 and 39, and those are both good examples to go over. So 38, again, think about that one big fraction and that you can cancel out the x's. So we'll have the square root of y over 3. Split it so that you can see the real problem here is that we have a square root of 3 in the denominator. And that square root of 3, remember, has that little invisible index of 2. So we have to make sure its power matches that index. So that means we're going to need another square root of 3 to the first to make that happen. And whatever we do to the bottom, we have to do to the top. So in the denominator, we now have the square root of 3 squared, which is great because that's just 3. And on the top, we have the square root of 3 times y, which is the square root of 3y. And there it is. That's as far as we can go with that one. So that was number 38. Number 39, when you look at this one, you realize, well, there's not anything that I can cancel out. So when I have the cubed root of x squared over 3y, that's not helping me as one big fraction, so I better split that up and then figure out how I can get rid of that cubed root of 3y in the denominator. Well, I need cubed root because cubed root can only be multiplied by other cubed roots. And I see I only have 1 3 and 1 y. I need 3 of them because I need my power to match my index. So I'll need 2 more 3's and 2 more y's. So my denominator is now going to be the cubed root of 3 to the third y to the third, which is great because that's 3y. And up here in the top, I have to do 3 squared, which is 9, so cubed root of 9, and then I have an x squared and a y squared. And that just comes along for the ride. Because this one was really about rationalizing the denominator for number 39. The remainder of the homework problems were from the book. Those you will find in the 6-2 Day 2 homework frequently asked questions video. So again, if you're looking for the homework problems that were in the book, those word problems are part of the 6-2 Day 2 frequently asked questions video, so you can go back to that one and see those.